Welcome to IKYA Global Private Limited. This video helps you to understand what is CAD CAM CAE, what is the use of mechanical design tools, why we use this mechanical software, who are eligible to learn this tool, and what are the companies are there working on this CAD CAM CAE, what is the qualification it requires, what type of work we have to do. These are all things you will understand in this video. First thing is, see here, CAD CAE CAM. CAD means computer aided design. CAE means computer aided engineering. CAM, computer aided manufacturing, for a manufacturing design. To manufacture a part, first we need to create that part, some software tool, CAD tool. We can also call it as a CAD tool. First we create a basic sketch on a paper or a drawing sheet. After that, we can't directly take that basic drawing, 2D sketch, into manufacturing. For that, before that, we need to create that sketch into a 3D model. Means we need to see its structure, its shape, by using some software before it is manufactured. For that, we use CAD, computer aided design, and there are different CAD tools, CAD softwares we use under CAD. One is Autocad. See, this is the Autocad screen. Autocad is a software used for creating 2-dimensional and 3-dimensional modeling. So Autocad is a basic software where we can generate drawings. See, this is the AutoCAD screen. This is one of a CAD tool, basic software. See, these are all options here you can see on AutoCAD. See, if you select a circle, we get a circle. Like these options we use in this tool. See, rectangle, a profile, polyline. There's some options like this. This is one of the software tool, but AutoCAD is extensively used for a 2-dimensional drawing. We can't use this for a 3D modeling because AutoCAD is a non-parametric modeling. It is you'll find difficulties in a modification or editing of a drawing of a model done. AutoCAD is used only for a 2-dimensional 2D. If the company requires only 2D layouts, then AutoCAD is the best software. The other software used in CAD department is CATIA V5, Creo, Unigraphics, UGNX, SolidWorks, Inventor. So these are all 3D modeling softwares. Apart from AutoCAD, we have some more 3D modeling softwares under CAD department. And the difference between each software, see AutoCAD, CATIA. See, CATIA is a 3-dimensional software which has a number of modules. See here, this is a CATIA tool where you can see number of options. The difference between one software and the other software, in CATIA you can see some advanced tools, different modules. See, when you go to start here, you can see number of modules, infrastructure, mechanical design, shape, analysis and simulation. See, these are all different modules you can see in CATIA V5. For a mechanical design, we need to use 6 modules. We have to learn. If you are interested in to come into design side, then you should have a knowledge on minimum 6 modules or workbenches. One is a sketcher, another one next is part modeling, next drafting, next assembling, next sheet metal, and surface modeling. So these modules we can see in CATIA V5, and also we have the same modules in SolidWorks also, Creo also, UGNX also, Inventor also. But CATIA and UGNX IHN software, which has advanced tools which you can generate any type of complex shapes, complex structures. See, I just open one CATIA model. See, this is a CATIA surface model. File, open. See, this is the CATIA part. See, part modeling looks like this. File, open. I also open drafting workbench. See, once you create this 3D part, after creating 3D part, the main thing is we need to take this part into manufacturing. So we can't directly take this part, we can't show like this to the manufacturer, and we can't ask him to produce this part. So what a manufacturer requires? Manufacturer requires a drawing, means its front view, its top view, its side view, its section views. These are all things we need to apply. So for that we need to take this part into drafting. See, this is part modeling workbench on CATIA. Then go to start mechanical design, drafting. Drafting is a workbench where we generate different views. We apply symbolic representations like tolerances, roughness symbols, welding symbols, and we take output. Drafting is nothing but output for this 3D tool and input to the manufacturing. See, this is a drafting, another workbench. Not only CATIA, the same modules you can see in Creo, SolidWorks, or Unigraphics, UGNX. See, go for front view. See here, or I take multi views, front, top, left. I select that part. See, we get like this: front view, top view, side views, whatever views. Still it has so many options. All options I can't explain in this demo class, just some basic options. And we need to apply dimension like this. Going into dimension, select elements like this, we get. So we need to apply all the dimensions, roughness symbols like this, roughness symbols, whatever the manufacturer required. We need to show all this on this drafting workbench, and we need to take a printout. See, you can go for a print, or you can save into PDF, whatever. See here, we can save this file into PDF, and we can take a printout, or we can send this file to the manufacturing. So this is the drafting module. And assembly module, if you want to assemble 2 or more parts, we need to open assembling. See, assembly, I just open one assembly module. File, open. See, this is a simple basic assembly which has a number of parts. So this is another module on CATIA V5 or any 3D software. where we need to apply different options. Here you can see there are different options here. Nothing but we need to call one by one part, each part, and we need to clamp. And next is surface modeling. Just I opened a surface model also. See, this is surface modeling, which has no thickness. This is one example for a surface exercise. See here, it has no thickness. The part which has no thickness, we call it as the surface modeling. So this is a one type of module, and it has a different option. See, to get into surface modeling, shape, generative shape design. These are all the options we have on CATIA V5 surface modeling. And next one is the sheet metal modeling. To get into sheet metal, mechanical design, start mechanical design, go to generative sheet metal design. See, these are all toolbars changed. Sheet metal option. CATIA, whether it may be a CATIA or UGNX or SolidWorks or Creo, common these modules we see in those tools also, in those softwares also. But whenever there is a work, if company is working on a surface modeling, then the company prefers CATIA V5 or Unigraphics. So based on the work, based on the product, the company prefers a particular software. See, CATIA mainly used for a surface modeling, part modeling also, but mainly if the shape is a complex shape, then we need to get into surface modeling. In that case, companies, automotive companies and aero companies, they prefer CATIA or UGNX. And the companies working on only part modeling and sheet metal modeling, they prefer either SolidWorks or Creo. If the company requires the basic tool where they are producing some simple design parts, they go with the inventor. Then if the company working only on a 2D, they prefer AutoCAD. Like this, based on the product, based on their design of the product, the company prefers tools. They buy license on particular tools. So for all these modules, the company hires only a BTech, a mechanical or aeronautical or automobile engineers. No other departments can get into this field, because in this field the candidate required some engineering knowledge, like drawing knowledge. In the drawing, they need to identify front view, top view, side views, section views. They need to understand some drawing concepts, some machine design concepts. The candidate should have some production technology concepts, like this, when machineries, lathe machines, milling machine, why these machines are used. So to get into this design field, the company requires some basic engineering knowledge. So they only prefer these streams, mechanical, aeronautical or automobile. No other like ECE, electrical, they won't prefer. So under CAD we need to create, we create a design, 3D design, we generate a design, we create a 3D modeling, assembling, drafting, all this comes under CAD. Then what is the CAE, computer aided engineering? Here we test the part, we do analysis on the part. After designing a part on CAD, we can't directly take this to the manufacturing. Do some analysis on that part. See here, there are different parts, universal coupling, knuckle joint. So when it is assembled, you need to calculate the stress on the part, load on the part, vibrations, pressure. There are so many analysis we need to check. We can't directly take that part to CAM. If you take that part to CAM manufacturing, then after producing the part, after that when you assemble, when the actual load applied on that, if it can't withstand, if it fails, then a lot of time as well as money will be wasting. After designing a part, before getting into this manufacturing, we need to do analysis, computer aided engineering. We use different tools as we have different tools on CAD, on CAE also we have different tools. Mainly we use ANSYS to do analysis on the solid, on the parts we use ANSYS. Before taking the part to ANSYS, we need to mesh the part. Meshing. Meshing means nothing but to break those part into number of elements. So for that also we use different tools like hypermesh, isomesh. These tools we use for meshing. After that we take that part to ANSYS, we do analysis whatever. After that we different testing on different materials. Then once it is okay, then the part is taken to the manufacturing, computer aided manufacturing, where it has a number of machines, CNC machines, computerized numerical control machines. A programmer writes a program according to the shape of the part. Then production starts. So this is the product life cycle of a CAD CAM, where every mechanical engineer, after their completion of a graduation, they have to know these things. See, product cycle, you can see product life cycle for almost every side. If you go for a software, they will be having a product life cycle. How the input first comes from the client and how delivered from the company. So this is nothing but the product life cycle, and this product life cycle is for CAD CAM, where every department, either it is CAD, CAE or CAM, requires a mechanical or a aeronautical or a production or a automobile engineering. Based on their tool knowledge, they will get a job into these. So for a fresher, it is better to learn some multiple softwares, some 2 or 3 softwares on CAD and 1 software on analysis. So company get a call from the company which are using these tools, so they can attend multiple interviews in multiple companies. Only few companies uses all tools, like in design side they use most of the tools, analysis most of the tools, but not every company will be using all tools. CATIA and UGNX are high-end softwares, where automotive and aero companies uses these softwares. And if you get a job into this, you will get a good salary also, compared to other tools like AutoCAD, SolidWorks, Creo. And analysis also, if you are well and good on analysis, then you will get analysis and salary will be also good. But most of the cases on analysis they will prefer experience, and CAM also they prefer experience, some CAM programming like that. So for all streams they prefer either a diploma in engineering or a degree in engineering. After manufacturing the part, then it is taken to the quality check, where manually they check with the instruments, they check its precision values, whether all the tolerances are maintained or not. Then it is sent to customer, client. So this is a product life cycle of CAD, CAE, CAM. As I have opened only 2 softwares, so this is the AutoCAD software, where we can use 2D and 3D, and this is a CATIA software. Already I have told you. Same in the other softwares also, we need to use the same type of modules like sketcher, part modeling, drafting, assembling, sheet metal, and surface modeling. See, just this is one example on AutoCAD. Nothing but this is nothing but a jig boring work. where you can see number of holes, to drill number of holes on the like a plate of some thickness. So this is done in AutoCAD. This is AutoCAD Drawing, a plumber block. AutoCAD is the best software where you can create any type of a 2D drawing. And this is a pipe vise, which is done in a CATIA V5. See, this is universal coupling assembly module, where we need to design each and every part separately, and we need to call each and every part one by one, and we need to assemble by using assembly constraints, assembly commands. The same type of assembly commands you can see in the other softwares also, but the names are different, but the usage is same. See, this is one type of a duct which is created in a SolidWorks, and the color is applied for this duct. That's it. See, this is also the product, the assembly part, knuckle joint, which has a different parts assembled in SolidWorks. See, this is a staircase which is created in UGNX. So it has different softwares, different commands, where you can get this type of output. So the basic difference between each tools other than AutoCAD is you can see some options, more number of options in UGNX, CATIA compared to SolidWorks or Creo. Some options you can see in CATIA, some options you can see in UGNX, which you don't have in a CATIA. Like that, there are different options we can utilize. This is a surface design on UGNX. This is also UGNX assembly design. This is assembly design done in UGNX. So some wheel assembly. Same in assembly in UGNX also. We need to create each and every part separately, and we need to call one by one part, and we need to assemble. This is AutoCAD assembly drawing. AutoCAD assembly drawing. See, this is a butterfly wall. This is a 2D drawing. If the company requires a 2D drawing, then you need to generate like this. Each and every drawing in AutoCAD you need to create like this. And this is the bill of material, listing all the parts, its description, quantity, etc. This is title block. This is a surface modeling part only, created in a UGNX. So like this, these are all like a photo picture of the modules, the parts done on different modules, because it is easy to open like this in a JPG image. But if you open the part, particularly file opening a part in the tool takes much time. See, that's why I'm showing on image. I have captured the image and I have shown all those things. See, if you open like this, see, this is one type of part. We use the different softwares, different tools for a 3D modeling, for designing mechanical parts or manufacturing parts, whatever. Mainly these tools for a manufacturing design. The part which is going to manufacture, it requires a basic data, design data, product data. For that we use these tools. So for a mechanical engineer, after finishing his graduation, there are two ways. You can either go into core side, means industrial side, or you can get into this design side. See, core side means industrial side. You need to work as a maintenance engineer or a production engineer, quality control engineer, or some shift engineers. You will be designated as a shift engineer, maintenance engineer. Like this you need to work, but the salary will be less and the work will be more, polluted environment. All these things you need to face, and you can't see much increment after 1 year or 2 years, whatever, according to company norms. And if you get into design side, you need to learn. If you are interested to get into design side, what the requirements a candidate need means, you should be very perfect. Simply learning a CATIA or whatever the tool is not enough. You should be perfect. You should be perfect on that tool, on all the options, on any tool, whatever he learns. So you should be in a position that whatever the command, see, if he asks what does this rip command do, then you should be able to answer. If he is, you should be a perfection on a tool. At the same time, simply learning of any CAD tool is not enough. Apart from this software knowledge, you should have a good knowledge on technical side, technical concept. See, again, what is this technical concepts means? Apart from that, you should have a good knowledge on a drawing concepts. First one is drawing concepts. So what are all included in the drawing concepts means, first you should be able to read the drawing. For the part, see, if this is the part, see, front view, this is front view. Okay, model we can turn and we can see front view, top view, this one, side view, this one. But the designer, the design engineer, CAD engineer should be in a position to create manually by seeing that, yeah, this is the front view. You should put on paper. This is side view. This is section view. This is top view. You should have a knowledge on that. So you need to practice on that to get a job into this design field. Front view, top view, side view, section views, and Gdnt symbols, drawing symbols, roughness symbols, welding symbols, all these things he need to learn. He should be thorough with the drawing concepts. First thing, Gdnt. Gdnt means geometrical dimensioning and tolerancing. Why we use these Gdnt symbols? Gdnt again categorized into geometrical tolerance, dimensional tolerance. Why we need to apply this Gdnt? Where we need to apply? What type of a symbol we need to apply? See, in Gdnt there are around 14 symbols. So where particularly need to apply, those things you need to learn. If you go to Google and if you type this Gdnt, then you will get n number of materials. You can just go through. And at the time of interview, in interviews they won't ask only questions on this software. They ask questions on drawing concepts. They ask questions on Gdnt concepts. After that, first one is a drawing knowledge. Second one is Gdnt concepts. And the third is some manufacturing processes. See, we have seen different manufacturing processes like casting, injection molding, machining, or forging. At least they should have a minimum basic knowledge. Okay, this part is produced in casting. Why it is casting? Why casting preferred? Why casting manufacturing process preferred? Those basic knowledge you should have. Then injection molding, plastic, how the plastic part has been manufactured. Why that particular part is preferred? Plastic material is preferred. The reason you need to know. And the material you should know, material concepts. What type of material you use for particular so and so plastics? What type of material you used for casting? It may be aluminum casting or steel, whatever. And another manufacturing process is press machines like sheet metal. How the sheet metal parts are created. What type of machines we use to generate a sheet metal part. What type of material we use for a sheet metal part. What are sheet metal processes? There are different processes, stamping, punching, all these things you should know. Why at particular place a sheet metal part is used? You need to know the reason why we are using that. Sheet metal or machining. No, this part is done by machining on machines, milling machines. Why we need to go for a milling machine? Why can't that particular part manufactured on casting? The reason mainly is this cost. This cost depends upon the cost, the part per unit value and the manufacturing costs related to each other. If the component cost is more, you will get a more per unit price. Then you can go for some precision machining. Or if the component is cheap, so suppose some box type, you need to place some elements, some items in the box. Soap box. So for that we won't go for a casting or a sheet metal because its component unit cost is less. So the cheap and best we can go for a injection molding. Apply a plastic material which is cheaper in price, one type of a material, then produce. So these things a designer should know. Of course, no need to get a knowledge in depth. But for a mechanical engineer, after pursuing his graduation to get a job, after graduation and getting a job, in between you should learn all these things. You may think that why I need to learn? I have to design on the system, sitting in front of system. Then why I need to learn all these manufacturing concepts? At the time of an interview, you'll ask questions like this. Because the job will be only, the positions will be only some 5 to 10. If you think 5 to 10 positions required for that company, then candidates attending for interview will be in thousands or hundreds. So ratio is more. Then how they will screen? Simply they will ask the basic questions on this tool. Everyone will answer. Then whom they prefer? Who has a much skill and knowledge. So they go in depth to filter majority of candidates. They need to filter by asking some typical questions. Okay, what you are designing, you need to know what for, what type of material used, what type of manufacturing process is used, and also you have a knowledge in you will be having a knowledge on in your educational background. So based on that, they will ask questions. If you are capable to answer all these things, drawing concepts, Gdnt concepts, manufacturing process, then product design concepts. Here product design means, see, the part may be either plastic or casting or sheet metal. See, for these there are separate design considerations. See, for example, plastic. Why we need to use the thickness, less thickness for plastic? Why can't we go for more thickness? What happened? See, when you see all the plastic parts, the thickness will be less than some 2 mm, 3 mm. That's it. You can't see more thickness plastic. Why? What happens if you increase the more thickness? If the plastic load and the plastic part should withstand that load, then what you will do? What type of a design characteristics you prefer? And like ribs, we use ribs, gussets like that. Then what is its design considerations? How much thickness you use for that ribs? What is the height for that rib you prefer? So these are all things comes under product design concepts. Sheet metal part. How much thickness you consider for a sheet metal part? What are sheet metal operations? How you do punching? How much space you use, you prefer? If you want to create a hole on the sheet metal, then from the edge, how much space you need to give. Radius, bend radius. How much bend radius you need to prefer. Outer radius and inner radius calculations, K factor. These are all design considerations comes under sheet metal. And casting also, you need to consider. For casting, you need to use so many things. Sprue, gate, risers, runners. All these things, you should have a knowledge, just knowledge, that's it. No need of a experience, no need of a working experience on that. Because we are not into that manufacturing, we are not going to work on a manufacturing side. But being a designer also, if you have a knowledge, then you will get within less time you can get a job in a company. Only learning only tool, and if you keep on attending interviews, then you can't able to give answer to all the questions they have. If having a knowledge on all these concepts, then if you keep these topics in your resume also, see, software tools I learned so and so, then technical concepts, I have a good knowledge on drawing concepts, I have a good knowledge on a Gdnt, I have a good knowledge on a manufacturing process like a casting or a injection molding or a sheet metal. I have a good knowledge on product design. Anyone, either it is a plastic or a sheet metal, then your resume will be, if they see your resume now, then you will get a call immediately. Because all other freshers will be keeping just I have a knowledge on so and so tool, that's it. Technical concepts they won't mention. Then the company, okay, this candidates particularly mentioned a lot related to this, let me call and we check. Then if you are able to answer, if you are able to respond in an exact way, if you deliver all the technical terms whatever you learn, then a mechanical engineer can get into this design field. So these are all the basic things. These are all the basic things which you see in CAD CAM. If you want to get into this CAD CAM, you should have a knowledge on these things. Why CAD, why CAE, why CAM, what is the product life cycle, what type of a companies in CAD, CAE, like this, automotive and aerospace companies, even electrical companies are also using this design softwares. Electrical companies like Bajaj Electricals, Usha Electricals, Crompton and Greaves, for their companies also they are hiring. And all automotive companies, even software companies, you can see Cyient, Tech Mahindra, HCL, Wipro. These companies also they are hiring CAD CAM because they are getting projects from abroad, CAD projects, CAE projects. They are hiring design engineers. If you get a job on analysis, then test engineers, CAE analyst, you will be called as you will be designed as you will be designated as a CAM, computer aided manufacturing. For that you need experience. If they hire a fresh mechanical, then they will make you to work on a machine operator, CNC operator, like that. They prefer a diploma in mechanical engineering. If you are interested to work as a machine operator, CNC operator also, they will hire BTech a fresher, where you can get a good knowledge on that machines. That also good working. So all these for all these companies, they only hire BTech mechanical or aeronautical or automobile engineers. So before entering into this field, every student who are interested into this coming into this mechanical design, manufacturing design, you should have at least the knowledge on these things. And here we in this institute IKYA, they handle all these software tools, CAD tools. There are number of trainers under CAD, under CAE, and also there are trainers who teaches uh, drawing concept. Trainers on technical side, they teach drawing side, engineering drawing, machine drawing. They teach Gdnt symbols, why we use this Gdnt symbols, and we have trainers who have experience on this manufacturing side. They explain manufacturing concepts also, along with the product design also. So this is a brief demo on CAD CAM. If you have any queries, if you want to know more information, if you want to speak with a faculty, whatever, just make a call to IKYA Global Private Limited. Make a call to institution and get your doubts cleared. Thank you for listening this demo.